Okay, this organic chemistry video is going to be talking about resonance structures, a step-by-step guide. Let's review the rules for resonance. The atoms will never move, only electrons move. Orbital hybrids do not change between structures. The most stable form contributes the most to the overall hybrid. These are how we find what is the major contributor. These 4 criteria are listed in order of importance. So today we're going to do 2 examples of resonance, and we're going to do step by step how to solve them. Okay, here's the first structure. I would suggest you pause your video and try to at least make one resonance structure from the structure I have given you. Remember to check for your formal charges, as I may have not written them down. We're going to draw 3 resonance structures for the structure I have given above. First off, we need to find our formal charges. Carbons like to have 4 bonds. All of our carbons have 4 bonds. Oxygen likes 2. Nitrogen usually likes 3 bonds. Since he has an extra, he's going to be positive. I like to circle my formal charges because they're easier to see that way. Formal charges help you see how electrons might move in a structure. So the double bond right below the nitrogen could give the nitrogen some electrons, but then it's going to take electrons from carbon. So redraw your structure. Don't lose any atoms. Or electrons. Alright, so this carbon only has 3 bonds now, so he is a carbocation. He's positive. Nitrogen has 3 bonds. He's neutral. And oxygen has 2. So he's also neutral. This is our first resonance structure. Now we can push electrons up to the oxygen, and electrons can come down from nitrogen to help that carbon be happy. So redraw your structure, don't lose any atoms, and don't lose your electrons. Keep track of all of your electrons. So nitrogen is a positive like we started with. Oxygen only has 1 bond, so he's negative. Now we can draw one more structure and just push those electrons up to oxygen, and we won't take any electrons from nitrogen, just to see what that would look like, because it is a significant structure. Formal charges are important. That carbon lost electrons, so it has a positive charge. Okay. Now that we have 3 resonance structures, we are going to circle the major contributor to our resonance hybrid using the criteria given at the beginning of this video. So the first criteria is to have a full octet. That all atoms have a full octet or have all the bonds they need to have 8 electrons around them. Any carbocation does not have a full octet, so our major structure is actually the structure that we started with, because all atoms have an octet. And that is the most important criteria for deciding what is major. Awesome. So we are going to list the hybridizations of nitrogen and oxygen in this structure because we know hybridizations do not change between resonance structures. So, nitrogen has 3 zones of bonding. So he has an sp2 hybridization because he can do pi bonds. Same with oxygen, he has an sp2 hybridization in all 4 of those structures you see. Okay, let's move on to the next example. Again, pause your video and try and work through this. We're going to draw 2 resonance structures for the structure I have given. Check for your formal charges first. Oxygen has 2 bonds, all the carbons have 4. Except that carbon, he has extra electrons, so he is a carb anion, he is negative. Awesome, that shows us where we can move electrons. So we're going to take those electrons, fold them to the left, and push the electrons up to the oxygen so that that carbon doesn't have 5 bonds. Alright, so our formal charge is going to be on the oxygen. It has a negative charge because it only has 1 bond. And it normally likes to have 2. Now we could go the other direction and go to the right and make another form from the original structure. Our electrons end up on that carbon, so that carbon with the electrons will be negative. Okay, now we're going to circle the major contributor. Oh, I'm just showing you how you can get from the second structure to the last one. That's just extra information for you. We're going to circle the major contributor. Since all of them have octets, that's not what we're going to be looking at. They all have 1 charge, so we go with the one that has the negative charge on the most electronegative atom, which would be oxygen. Carbon isn't very electronegative. Finally, what's the hybridization of oxygen? Oxygen has pi bonds and 3 areas of bonding, so it's sp2. Awesome. Good luck as you study organic chemistry. I hope this video helped you. You can do this, rock this class. Subscribe for more videos from me. Let me know what else you would like to see in the comments.